Welcome to lesson 12, problem number 2. Feel free to use your calculator anywhere on this problem. And we're going to get started by following the hint, defining variables. I'm going to assume you read each one of these problems, so we're going to jump right in. So in the first problem, we can actually go by the question to know what to let the variables be equal to. It says, how many regular gems and how many rare gems did the players find? Okay, so we're going to say let x, I'm just going to let x equal the regular gems found. I'm going to abbreviate that, so regular gems. And let's let y equal the rare gems. Okay, and what we know for sure is that x plus y is equal to the total gems found of 10. And we also know that we get 9 points for regular gems. So 9x is the total points we get for the regular gems. 11y is the total points we get for the rare gems. And altogether, we've earned 96 points. So now let's take that first equation and let's just get x alone. So I'm going to rewrite that first equation as x equals negative y plus 10 because I can subtract y from both sides. So now that x is equal to negative y plus 10, I can go to this equation and rewrite it with negative y plus 10 replacing x based on our knowledge of substitution. So I now get 9, and instead of x, I'm going to write negative y plus 10 plus 11y equals 96. And soon enough, we're going to know exactly how many regular and rare gems we have. So negative 9y plus 90 plus 11y equals 96. I'm going to kind of move over here with it. I'm going to combine the negative 9y and the 11y. So together, they're going to give me 2y, and they're on the same side of the equal sign, so they can just go together. So 2y plus 90 equals 96. Subtract 90 from both sides, and we get 2y equals 6, and y equals 3. So I can go back over here, and I'm going to change our color again. The number of rare gems is 3. Since x plus y must equal 10, the number of regular gems must be equal to 7. And we have answered a question. Okay, so for this next problem, we're going to need a little extra space. So I'm going to zoom in just to know you're not going to see this, but you're welcome to email me anytime, and I will answer your questions. Okay, let's go to this next problem and make it a little bit larger. So in this case, we have to let x and y equal different types of liquids. And what we know is that one liquid, let's say x, has 10% acid. So I'm going to say let x equal gallons, I'm going to abbreviate that, of the 10% solution. Okay, I'm going to abbreviate a lot. Y is equal to the gallons of the 80% solution. So we're trying to combine these two solutions to get a 65% solution. Now we want 4 gallons altogether. So what we already know is that the number of 10% gallons plus the number of 80% gallons has to be equal to a total of 4 gallons. Not only that, but we also know that out of each gallon of the 10% solution, 10% of it, which we could write as 0.10, but I'm going to even make it easier. Instead of making it 10 100ths, I'm just going to make it 1/10, which a lot of people just say 0.1, but it's really 1/10. So we're going to say 1/10 x plus 8/10 or 80% of the number of y gallons. So I'm going to say point y, which is really 8/10 y. So this is where it gets a little tricky, and I want to take a minute and make sure you recognize this is a light bulb problem, which is why it's tricky. But 10% of the number of gallons of the 10% solution, this is the amount of acid we're getting from the 10% solution. This is the amount of acid we're getting from the 80% solution. And altogether, 62.5%, which we know is 625 1,000ths. That's another way of writing 62.5%. So that decimal times the total gallons of 4 will tell us how much acid we're going to have altogether. So if we take 10% of the gallons of the 10% solution and we take 80% of the gallons of the 80% solution, we're going to get a bunch of, like, lots of gallons of acid, and that's going to be equivalent to 62.5% of our 4-gallon solution. All right, time for substitution. So I'm going to rewrite this equation again. I'm going to write it as x equals negative y plus 4. This is why your calculator will be handy. We're going to replace this negative y plus 4. We're going to substitute it in for that x. So I'm going to start by saying 1/10 of negative y plus 4 plus 8/10 of y. I don't even really need a parentheses there. We could just say of y equals, and here's where your calculator will come in handy, but this 625 1,000ths of 4, we could actually multiply that all the way out. But what I'm going to do, I'm going to rewrite it this way first, and then I'm going to ask if we could do something a little bit different, just to show you we could do it without a calculator. Just to get rid of the decimals, I'm going to multiply this entire equation through by 10. And what that's basically going to do is it's basically going to move all these decimals over one position to the right, because 10 times 1/10, it's just 1 times negative y plus 4 plus 8y equals, and now I'm going to say 6 1/4, or 6 25 100ths of 4. So the reason we no longer need a calculator, and we could do this in our heads, is the first part, I'm just going to go from left to right, is negative y plus 4 plus 8y equals, and when you think of 6 times 4 is 24, and then this is the equivalent of 1/4 of 4, which is just 1. So altogether, we're just going to get 24 plus 1, or 25, and I no longer needed a calculator. Okay, combine our y's together, we get 7y, subtract 4 from both sides. 7y equals 21, y equals 3. So we need 3 gallons of the 80% solution, meaning since we have 4 gallons altogether, we need 1 gallon of the 10% solution. Great. Okay, let's go to the third problem here. And this one's going to seem not so tough after that very challenging light bulb problem. So J has a total of 25 points. So I'm going to let X equal number of nickels, Y equal number of quarters. Let X equal the number of nickels, and Y equals the number of quarters. Okay. All right, so now, a nice cue there. Okay, we have a total of 25 coins. So X plus Y equals 25. And then for every nickel, we get 5 cents. So what I'm going to do is I'm going to write it first as, that's how we write 5 cents, because it's 5 out of 100 times the number of nickels plus 25 100ths times the number of quarters, which is Y, and that's equal to $4.65. I'm going to use our little strategy, though, of getting rid of decimals, and this time I have to multiply through by 100 because I want the decimals to move 2 to the right. Our new equation becomes simply 5x plus 25y equals 465. I'm going to go back up to the original equation here, get x alone so I can do substitution. X equals negative y plus 25. Take that negative y plus 25 and substitute it in for x. So I now have 5 times negative y plus 25 plus 25y equals 465. And so far we haven't needed a calculator. All right, let's do it from here. So negative 5y plus 125 plus 25y equals 465. And now we have a couple more steps. The negative 5y here and this 25y is going to give me 20y. So I'm going to rewrite that here, 20y equals, I'm subtracting 125 from both sides, so I'm going to get 340. So y is simply equal to 17. So we have 17 nickels. So I'm just going to say 17 equals number of nickels. And since there are 25 coins altogether, we know that 8 is equal to the number of quarters. And you can actually look at it and show that it works, but this is it. All right, great job. See you next time.